Hello everyone, in this video I explain the changes I made to EMADL to create the 3D-GAN. There are some changes, new layers, as well as some changes to already existing layers. And let's start with the new layers right away. So we have two completely new layers, convolution 3D and up convolution 3D, which are convolutions for 3 dimensions. They have a kernel name, channels, and strides, where we use tuples as an input. We also have a no bias from MXNet, and we have padding. And the difference for these convolutions to the old ones lies mostly in the padding, because now we can use the padding keywords, which we already have, including a new one, simple 3D, but we can also provide tuples as a padding because of the new padding type 3D and transpadding type 3D. An example of this you will see later. And else there's not much to say about these. One restriction is there to the up convolution layer. MXNet only allows this on graphic cards, so you need a graphic card to make transposed convolutions in 3 dimensions. And for this gun as well, we need a graphics card, which is why it does not currently work in the Git pipeline. Another new change is a change to Archetype symbol, which is the internal representation of data. We have now in the builder a check if a depth was given, and if it's not, we create the old list. There's nothing new to this, but if there was a depth given, we create a new depth, which is different in the order, because in MXNet depth comes for height and width. In the convolutions, so we do it the same way here. And if you actually want to use 3 dimensions or 3-dimensional data in your in any layer and it's not already implemented, you would have to do it this way. So currently the way I did it was I checked for if the depth index was different to -1, or I checked if it's -1, and if it is, then it was not set. So I'm assuming the data is 2-dimensional at best, and I'm creating a normal archetype symbol. But if it's different to -1, the depth index, then I'm assuming a depth was given, and I'm taking it down here and providing it to the archetype symbol builder. And in that way you would have to implement 3-dimensional data input for any of the layers you want to use. Now to the generator of 3D-GAN. As an example, the discriminator is built up exactly the same way, but I just want to show how especially padding can be tuples as well as keywords. Simple 3D as a keyword actually stands for the constant padding of 1. So these two are actually interchangeable, but both works fine. And this is the up convolution layer. In the discriminator we use the normal convolution 3D layer, and kernel, channel, stride all set as we know it, but padding is just the different parameter right now with the two builds. Yeah, right, and that's it. Now I want to show you some examples what the 3D-GAN can actually create in objects. So this is one example of a created object with some of the pre-trained parameters which are available in the GitHub. As you can see, this is a sofa. The quality is not the best. One reason for this is because it's a resolution of 32 by 32 by 32, so 32 voxels in each direction. But it's clearly identifiable, and it's just one of the different objects which can be created. This is another sofa again created. Now you can see that this is completely different to the one before, which is actually good. So it learned kind of the idea of a sofa more than just a straight rectangle, but it can also create some with corners. And by the way, this is visualized with MeshLab, which is free. You can download it online, and you need some kind of software to create these, to visualize these objects, because we only translate it into an OBJ file, and you need some program to call these up. And yeah, that's it from the 3D-GAN. I hope you now know how to use this and what changes were made during my thesis to especially allow 3D data input to happen, and you can use this in the future.